Okay, this is 5.2 for Pre-Cal 11, solving for angles in center position. There's a lot going on, and I'll try to slow this down as best I can to give you guys as much information as possible. The centered angle we're talking about is basically any angle from that line or at 0 all the way around. Your reference angle is any angle made with your horizontals. So you're basically your x-axis, whatever line you're dealing with, to your x-axis or the nearest x-axis is your reference angle. A little review from last class. If you're given a point and asked to solve, in this case the point's at 3 and 4, what they do is they put the point 3 and 4, and you want to solve your missing angle, or rather your reference angle, and your terminal arm side. Terminal arm side is just using Pythagorean theorem. A squared plus b squared equals c squared, in which case 3 and 4 are a and b, and it doesn't matter which one it is, because when you plug it into your formula, 3 squared plus 4 squared will give you 9 plus 16. Once we have 25 equals our c squared, in order to get c by itself, we take the square root of both sides. When we do that, we cancel out our squared function. We're left with the square root of 25 is c, therefore we know our terminal arm, or our side, c, is 5. To find our ratio, if we know 3 and 4, we can use grade 9 trig from last year to calculate our unknown side. If this is 4 and this is 3, and we're trying to find this, when we label this based off of this angle, this is our opposite side, this is our adjacent side, this is our hypotenuse. Using opposite and adjacent, we're going to use tan. And we know that tan theta equals our opposite divided by the adjacent. So tan theta equals 4 over 3. We take inverse tan, so tan negative 1. When we do that, we swap out our theta with our fraction. We punch that into our calculator, making sure our calculators are set to degrees. So, inverse tan of 4 divided by 3 should give us an angle of 53.13 degrees. And that is our reference angle. Which we kind of filled in down here. Now, based off of this triangle, we could write out our primary trig ratios. We want to leave them as a fraction, but based off of sine, cos, and tan. So sine, again, sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. And tan is opposite over adjacent. What we want you to point out here is 4 over 5 is a positive number, 3 over 5 is a positive number, and 4 over 3 is a positive number. These positive numbers are because we're in quadrant 1, where everything is going to be positive and positive, because your x-axis is positive and your y-axis is positive. As we go around the quadrants, that is going to change, because suddenly we're going to have a negative x and a positive y, a negative x and a negative y, a positive x and a negative y. We're going to show you guys a trick how to make sure we always have the correct numbers for our trig ratios. Something to note is your radius, or rather your radial arm, this guy here, is always going to be positive. This is because if you look at Pythagorean theorem, if you ever put a negative number in any of these squared terms, like negative 4 squared will give you positive 16. So you're always going to have a positive number for your radial arm. It cannot become negative. Next thing I want to point out is as we change into your different quadrants, so in our case, -3 and -4, again, x and y, so we're going to go -3, -4. Oh, I missed a quadrant. Oops. Second quadrant. For our second quadrant, we're going to go -3 and +4. So we're going to go back 3 and up 4. So this is -3, 4, and this will be a +5. We talk about our sine, cos, and tan ratios. Okay? Again, thinking back to SOHCAHTOA, which is where we're getting all these from. Sine theta is going to be our opposite over hypotenuse. So our sine theta is going to be +4 over +5. That's important. That's one thing we have to note. Cos theta, cos is the adjacent divided by the hypotenuse. So we're going to have -3 over 5. A -3 divided by 5 gives us a negative. Something to point out. And tan is going to be opposite over adjacent. So it's going to be 4 divided by -3, which is also negative. Understanding which sine ratio is positive and negative in which quadrant is what we really care about for this first part. There are 4 quadrants, and you're going to have to realize or find out a way to figure out which ratio is positive and negative in both. There's a trick at the end we'll show you, but I just want to see or show you where this is coming from. For the points -3, -4. So now we're in our third quadrant, right? This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. In quadrant 3, we have -3, -4. So we have the point. 5 is still positive, but again, our 3 sine ratios, our 3 trig ratios, based off our reference angle. So we label this is going to be the opposite, the hypotenuse, and the adjacent. Remembering SOHCAHTOA, so your sine ratio is opposite over hypotenuse. So -4 over 5. That gives us a negative ratio. Cos is adjacent over hypotenuse. So -3 over 5. Again, negative. TOA gives us a opposite over the adjacent. So we have -4 divided by -3. A negative divided by a negative is actually a positive. So for our third quadrant, we know that tan is going to be positive. For our fourth quadrant, we're going to use the point 3 and -4. So we have 3, -4. Again, terminal arm is always positive, so 5. And our reference angle. We're going to label this the opposite, the adjacent, the hypotenuse. Now we're dealing with SOHCAHTOA. Sine first, so opposite over hypotenuse. We have -4 over 5. That gives us a negative. Cos, the adjacent over hypotenuse, gives us 3 over 5, which is a positive. And tan, so TOA, opposite over adjacent, gives us -4 over 3, so it gives us a negative. If we look back at all 4 quadrants, we have what's called CAST. CAST, C-A-S-T, tells us what each ratio, or rather which quadrant each ratio is positive in. So again, we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So, in quadrant 1, all of them are positive. No matter what ratio we had, because everything was in the positive, every ratio is positive. In our second quadrant, the only ratio that is positive is sine. In our third quadrant, the only ratio is tan. And in our fourth quadrant, the only ratio is cos. So, because all of them are positive in our first quadrant, every single ratio is going to be positive in two quadrants and negative in two quadrants. So for sine, it's positive in our quadrant 1 and quadrant 2. For tan, it's quadrant 1 and quadrant 3. And for cos, it's quadrant 1 and quadrant 4. With this information, we know that if I gave you a positive sine ratio, and I said, okay, for sine theta equals 0.5, for which quadrants could this fall into? Because I'm dealing with a positive number, I know that I'm looking for where is sine positive? Well, sine is positive in quadrant 1 and quadrant 2. If I had asked you about sine theta equals negative 0.5, so we'll say quadrants 1 and 2. Because sine theta is a negative angle, in which ones is it negative? Well, if it's positive in 1 and 2, it has to be negative in 3 and 4. And this is true for cos, tan, and the other ones. So the CAST rule basically tells us which quadrant our trig ratio will be positive in. With that knowledge, we also understand which trig ratio it's going to be negative in. Okay, so every ratio is going to be positive in at least two of the quadrants and negative in two of the quadrants. And therefore we know that two of our angles will lie between 0 and 360 degrees will have the exact same ratio because they'll be positive in one. Sine is positive in quadrants 1 and 2. It's negative in quadrants 3 and 4. Cos is positive in quadrant 1 and quadrant 4. It's in negative quadrant 2 and quadrant 3. For tan, we're positive in quadrant 1 and quadrant 3. And we're negative in quadrant 2 and quadrant 4. You don't have to memorize this, but I would strongly recommend memorizing your CAST. It will help you greatly in the future. So, a standard question will look like this. Find the angle in standard position, or find the angles in standard position that have a ratio of sine theta equals 0.5. Basically, it wants you to find the angles that are between 0 degrees and 360 degrees that are of a sine ratio 0.5. So, there's 4 steps in doing this. First step is going to be look at your quadrants. I know I'm dealing with positive sine. Therefore, I have to be in quadrant 1 because they're all positive, and quadrant 2 because sine is positive. I then have to find my reference angle. If I've been given sine theta equals 0.5, I just have to find inverse sine, right? So again, go to your calculator and hit inverse sine. Because when I do that, inverse sine, I'm basically going to swap my theta with 0.5. So it says I have an angle of 30 degrees, which is good to know. Sometimes, if you're given a negative angle, like I said before with sine equals negative 0.5, that's just so you understand it's in the bottom, that's in the third and fourth quadrant. You must, however, put in the positive number in your calculator or else it'll give you an error. So, even though it'll say something negative, you must still put the positive when using your calculator. That negative, however, will tell you what quadrants you're dealing with. Step 3 is to put that reference angle, that 30 degrees, into our reference angle, which we know is our first angle we're dealing with, hence the 30 degrees. We then have to find our standard angle, which is again from 0 all the way over there. If we understand that this is also 30 degrees down here, and a full semicircle is 180 degrees, I can go 180 degrees minus 30 to find this angle here. 180 minus 30 is 150 degrees. So my final answer for my two angles at sine of 50, one's at 30 and one's at 150. Those are the 4 steps. There's a lot going on, but if you go slowly and understand the CAST rule and go step by step, it's not too bad. Example 3. We're going to find cos theta of negative 0.4, that is between 0 and 360 degrees. So again, step 1 is CAST. I know I'm dealing with a negative angle here. That's important. So negative angle. Normally, I'll go blue. Normally, cos would be positive in quadrants 1 and quadrants 4. But because we're dealing with a negative angle, we're actually looking at quadrants 2 and quadrant 3. Because it's positive in these two and negative in these two. And we're looking for the negative angle. We then type in cos theta of 0.4 into our calculator, right? Again, always making sure our angle in your calculator is positive. So, inverse cos. When I do that, I can swap my theta with 0.4. I get an angle of 66.42 degrees. I'm just going to leave it at 66 degrees. So I know that this angle down here is 66 degrees, and this angle here is also 66 degrees. However, the angles, your reference angle and angle in center position, it wants to know what this angle here is and this angle here is. So we got to do a little bit of math. I know that 180 degrees is a flat line, and if I go 180 minus 66, I'm going to get this angle right here. So 180 minus 66, I know that this is 114 degrees as one of my answers. My second one, this is 180 degrees, so I'm going to add 66 to get that extra part. So 180 plus 66 is my 246 degrees. Answer down here. We'll do one third example just to give you guys, or fourth example just to make sure everything's good and up to par here. So, I'm going to deal with tan theta, and while I wrote this out poorly the first time, I'm going to write it again. Tan theta is negative 1.5, so we're dealing with a negative angle here. So again, normally tan is positive in quadrants 1 and quadrants 3, but because it's a negative angle, we're only caring about quadrant 2 and quadrant 4. So we can draw in our lines. And we know that we're trying to find this guy, and we're trying to find this guy. We can use our reference angle, right? Based off the x-axis, we can find this, and we can find this using that tan negative 1.5. I'm going to go tan theta equals, in this case, positive 1.5 because I can't use a negative number. Take the inverse of that in my calculator. So tan negative 1, 1.5, again, positive, tells me that that angle there is 56, technically 0.3. We're going to round and say it's 56 degrees. So, if I know that that little angle down there is 56 degrees, I can go 180 minus 56 to give me my first angle, which is 124 degrees. And I can go 180 plus 90 plus, oh, I see what they did. We can go, because we know a whole circle is 360, we can go 360 minus that 56 to give us the whole angle, which is 304 degrees. This is the one where I'd really recommend going through your textbook for those of you going to Pre-Cal 12 and trying a couple of the questions. The book does a pretty good job of explaining this, and the 2 questions I'm going to ask probably is not adequate enough to have a full understanding, but it is something I can kind of test your knowledge for. So if I were you, I would go for section 5.2 in your textbook and go through about half the questions. For question 5.2, for the questions, question 1 is for the angle in center position. I want you to state which quadrant of the terminal arm where these could lie. Basically, if you're given tan theta equals 0.25, where is that based off of cast? Same goes for sine theta of negative 2/3. For question 2, which values of theta satisfy for the following, or where does it fall between 0 degrees and 360 degrees if you have cos theta equals 0.5? If you have any questions, I will be online Tuesdays and Thursdays for tutorial. Good luck.